Hello, Bearcats. Today we're going to analyze graphs of functions, which are really just our transformations. You're pretty familiar with all of this stuff, so let's just get started as a review. First, we're going to talk about vertical shifts. Vertical shifts would take your original function, your h of x, which would be like your original function, and it would turn into f of x. I'm sorry, h of x is your new function, would take your original function, f of x, and you would either add a value or subtract a value. So here it's represented by adding c or subtracting c. Vertical shifts would mean you would move up and down like the y-axis, vertically like the y-axis. So if you added, you would move up. If you subtracted, you would move down. Horizontal shifts, of course, would be moving right, left, and right. This would happen within the x. So near the x in the parentheses or under a radical, depending on your equation, but it would happen with x, so it's got to happen with the x value. Your new function would be your old function f of x, and you would either be adding or subtracting c from that x value. Remember, with horizontal movement, it happens mainly opposite of kind of what you think it's going to happen. So when it says x minus c, you would actually move to the right. When it's x plus a value, you would actually move that far to the left. All right, then we have reflections. Reflections are going to be represented by the negative sign. If you have a negative sign on the outside of your function, that would happen vertically. Okay, that's not with x, so that's going to happen vertically, up and down. Your reflection would be up and down. If it's up and down, then you're reflecting over the x-axis. And if it's happening with x, then it's going to be horizontal, and you would reflect over the y-axis. All right, let's move on to the next screen. All right, now we're talking about vertical stretch and compression or horizontal stretch and compression. Vertical stretch and compression is going to happen, again, outside the function. So your original function, f of x, it would be multiplied by a value outside of the function. Your new function would be multiplying the old function. So this c would be on the outside, or the value would be on the outside. If that c value is greater than 1, that's bigger than 1, 2, 3, 4, 5, then that would be a vertical stretch. Vertical stretch. If that c value is a fraction between 0 and 1, then it would be a vertical compression or a shrink. Horizontal, you have the same thing except that your c value, your multiplier, is on the inside with x, so it's going to happen with x. And remember, horizontal transformations happen opposite of what we think. So if c is a fraction, you're actually going to stretch, and if c is greater than 1, 2, 3, 4, etc., you're actually going to compress. So for example, if c was 1/2, you would actually stretch by 2. If c were 2, you would actually compress by 1/2. All right, let's move on to 4 examples. First example. The first example is f of x equals x to the 4th. That's our original function. We have moved from that to negative x to the 4th plus 2. We have 2 transformations here. We have the transformation for the negative, that would be a reflection, and we have the transformation for the plus 2. X to the 4 is just the original function. So we have 2 transformations here. We have a reflection, and because it's not with x, even though you might think that, if it were with x, it would be inside of parentheses. So it's vertical, that's going to be up and down, so it's going to be over, though, the x-axis. We have the second transformation is the plus 2 at the end. That plus 2 at the end would, of course mean we would shift up 2. All right, let's look at our second example. In our second example, we again start with x to the 4th. That's our base function. So x to the 4th is in there, but we have several transformations going on. We have a horizontal transformation, the minus 3. We have a reflection, the negative in the front. We have a plus 2, a vertical shift at the end. If you hopefully recall from your prior knowledge of transformations, you must do all your horizontal movement first. So your first transformation, if you were actually graphing, would be to do the horizontal first. Since it's x minus, you would actually go to the right, so you're going to shift right 3. Then you go back to the front of your equation and you have that negative, so that would be a reflection. And of course, that's a vertical reflection, so over the x-axis. And then, of course, last you have the +2, which would be shift up 2. All right, third example. We only have 4, just a couple more. All right, this is a square root graph. We're going to start. You would also have restrictions, by the way, on your square root graph. We know that the square root graph, the base function, the restriction, the domain would have to be, let's go ahead and write that. Your domain would have to be greater than or equal to 0. So from 0 to positive infinity. Just kind of letting you know that. We can talk about the restriction on your final graph in a minute. They wrote this first in notation, function notation. So they said they wanted f of x plus 2 minus 3. So the way you would really write that is the square root of x plus 2 minus 3. And they also have this reflection in the front. Let's talk about our transformations and then we'll talk about the domain. So in this particular case, we would take our horizontal shift first. So x plus 2 really means we would shift left 2. Then we're going to go back to our reflection in the front, which is not with x, so it's going to be vertical. And down, so over the x-axis. Oops. And then finally, the minus 3 would mean we would shift down 3. Let's talk about the domain in our new function, our g of x function. Remember, there is no restriction except under that radical. Under the radical, you could have a 0. To make it 0, you would say negative 2. Okay, and it could be equal at negative 2. Would you want values bigger or less than negative 2? If I made it negative 3, that would create a negative. So I think we're going to want from negative 2 greater. So negative 1, 0, 1, 2, 3. So to positive infinity. And that would be your domain for your new function. All right, last example, and it's a doozy. All right, again, we're going to start with our square root function. We have done several things underneath the radical, so several things are going to happen horizontally. And then, of course, we have this reflection in the front. If there is more, I wrote this down, you want to write this in your notes. If there is more than one horizontal transformation, you need to simplify it if you're going to use the basic rules of transformation. So we're going to do that next. When we simplify g of x, we're going to keep that negative, but underneath the radical, we're going to do a couple of things. We're going to factor out the negative, and we're going to factor out the 1/2. And then here's the tricky part. Negative 1/2 times something gives me negative 1/2 x, so that's just an x. But negative 1/2 times what gives me positive 3? Well, first of all, I need a negative, because a negative times a negative is a positive. And then what value times 1/2 would give me 3? That would be 6. So 1/2 of 6 would be 3. Now that we've simplified it, we can write our rules of transformation. So the first thing we're going to do is underneath all our horizontal movement. We have that reflection, so we would reflect over, and that's going to be horizontal reflection, so that's going to be over the y-axis. Then we have the 1/2, which is a stretch or compress because it's opposite of what you think. It will actually be a horizontal, a horizontal stretch of 2. And then we have x minus 6, so again it's with x. It's the opposite of what you think, so we're actually going to go right, shift right 6. And then finally the negative in the front, I'm going to write it over here, is we're going to have a reflection. And that would be vertical, and so that would be over the x-axis. And that would be the order in which you would have to do your transformations. All right, have a good day. Go Bearcats!